Hello students, hope you are doing well and you are also studying well. Welcome to this video. So in the previous video we had seen how to calculate the probable error by considering also the Karl-Pearson's correlation coefficient. So this is to find whether the value what we have calculated, that is the Karl-Pearson's correlation coefficient, whether it is significant or not. Okay, so this continuation with the same, we'll have this another example. For this example as well, we will calculate the value of first Karl-Pearson's correlation coefficient, and then we will check whether that value is significant or not by calculating its probable error and then comparing whether it is less than the probable error or it is more than its 6 times the probable error. Okay, so in these two cases we can surely say whether it is significant or not significant. And in the third case, nothing can be concluded. So we'll check for this value. Okay, so now overheads of one particular company are given along with the costs. So those are given in thousands actually. So the values are given this way. Now this is nothing but our variable x and this is our variable y. So first thing we have to calculate the arithmetic mean of x and we have to check whether that exists in this list or we have to check the nearby value with arithmetic mean and then we have to find the deviations for all. Same we have to do for y as well. So first let me find the total of all. Six two zero is the total of all the values in x and for y 620 is the value, the summation of x, and 582 is the summation of y. And we have total 10 values. So for x, its arithmetic mean would be 62, and for y, it will be 58.2. Alright, so we get the actual values of x bar is 6 and y bar is actual values we get this way 58.2. Now we'll check whether do we have value 62 in this list. So we have 62 here, so we can go ahead with this. So we'll calculate dx, that is x minus 62. And for y bar it is 58.2. For our convenience we'll make it 58. We will check whether 58 is there in the list. So in the list of y we have here 58 as well. So let me take arithmetic mean for finding deviations as 58. Alright, so we have fixed these two values. Now let me calculate them, that is dx and dy. So now here it is not in the orders, you may get the mixture of positive and negative values. So 80 minus 62 gives you 18. -60 minus 62 gives you -2. Then 51 minus 62 is -11. 60 minus 62 is 7. Sorry, 69 minus 62. 58 minus 62 is -4. Then this would be +4, 2, and so on. So these are the values we have got. Sorry, 62 minus 62 is 2 is 0 here. Then similarly we have to calculate deviations of y from 58. So 45 minus 58, we get minus 13. 71 minus 58 is plus 13. Then 60 minus 58 is 2. 57 minus 58 is minus 1. Alright, our deviations are ready. Now, if you look at the values, it is the combination of odd and evens here also. So, we don't see any possibility to find the common factor or to reduce, divide all of them by any common factor. Because here we have 13, which is almost prime number. It's a prime, 11 is also prime number. Same in this, well, we have 2, 6, 4, but 7 is there. It's a prime number, so we cannot divide it. So we have to go ahead with this dx dy. So then we will square them, dx square dy square. Then we will also find the multiplication of dx and dy. So this way it is. So dx square, square of 18, which is 324. Anyways, all squares are positive. So let me just write all these squares. So dx square is ready. Dy square are also ready. Now dx dy, we need to find the multiplication of dx into dy. So here we have to be careful. You have to check the negative signs. If you have one negative sign, you get the multiplication negative. If you have both negatives, then we get the multiplication positive. Okay, so now we don't know whether it is positive or negative correlation because it is not given in the order. But then again, if you check here from 80 to 60 there is a decrement. So from here 45 to 71 there is increment. So from 60 to 51 it is again decrement, and here 71 to 60 here also it is decrement. Nothing can be told, we cannot tell anything about sure. Now 51 to 69 is increasing, 60 to 57 is decreasing. So in first four cases three possibilities are there. Two of them increased and one decreased. So majority is, if you say increase decrease in the opposite way, we may get it the negative correlation. So we will check. So we have to be specifically take care about the negative sign and its multiplication. Now dx into dy, so this is a negative value we are going to get. So let me calculate. So 18 into minus 13 is minus 234. This is minus 26, minus 22, minus 7, minus 16, then 0, minus 20, minus 80, minus 24, and minus 44. All the values we have got minus because there is alternate minus here. There is no any case where we have negative for both of them. Here it is minus plus, here it is minus plus, minus plus, plus minus, minus plus. Same thing is for other cases as well. So we did not get any positive value, all values are negative. Alright, our all three columns are ready. Now we have to find the summation of all of them. Okay. So summation of dx square, let me find out. Okay, surprisingly we have got same summation for dx square and dy square, both of them as 660 and 660, and dx dy is going to give us the sum in the negative. Let me add. So this gives us minus 473. Alright, so we will substitute into the formula. So our formula, the old formula, that is summation of dx dy divided by square root of summation of dx square into summation of dy square. So this was the formula. So our summation of dx dy is minus 473 divided by summation of dx square and dy square. We have got both of them same, that is 660 into 660. So our calculation is really simple because it's the same number multiplied twice. So if you remove the square root, we remain with only one. So 660 into 660, their square root is 660 itself. So now for 473 divided by 660. Okay. So as usual, we have denominator greater than the numerator, and in this case denominator is much greater than the numerator, so we may not get value near to 0.9, and anyway it is sure it's a negative correlation. So let me calculate. So it's 473 divided by 660. So this gives me 0.71. 0.716. So our Karl coefficient we have calculated is minus 0.716. So it is definitely, it's not a high degree correlation, but it's a negative correlation for sure, because if it x increasing, y decreases, or vice versa. So this is, so from Karl Pearson's correlation coefficient we have found it's a negative correlation, and this is the value we have calculated. Now we have to check whether this value is significant or not. Okay, so for that we have to calculate the probable error. Now my value of, I've got 10 values. Okay, now in this case r square, even if it is negative value, we always get the squares in positive, so it doesn't matter if it is negative or positive value. You can put the value of r without sign or with sign. In the case of negative, ultimately we have to subtract it from 1, so there doesn't happen any change there. Okay, so but we have, when we compare the value of r, then we have to consider only its magnitude. We are not going to compare the negative value with 6 times greater than probable error. We have to compare the value with its only magnitude, neglecting the negative sign. Okay, so 0.716 and its square. So let me find this ratio. Okay, so the 1 minus r square is 0.4873 and the square root of 10 is 3.1622. So the final probable error what we get is, so the final probable error what we get is 0.1039. Okay, so now we need to check. Now the value of r is 0.716 and it is not less than 0.1039. So we have to check whether it is greater than 6 times 0.1039. So so this gives 0.62. So the r what we have got is 0.62, that, and then value of r is 0.716. So you can say it is greater than 6 times its probable error. So that's why this value is also what you say is highly significant. Okay. So by considering the probable error, what we have calculated is this value is also highly significant. So hope you have understood this example. So this is what, to calculate the Karl-Pearson's coefficient correlation, we have two methods. One is using dx dy, another method is using u and v. You can apply any method depending upon whether it is possible to reduce all the values, okay, by using any common factor, and then you have to check. So if it is asked to also check whether the value is significant or not, then we have to go for calculating its probable error and compare whether r is less than probable error, then it is not at all significant. If r is greater than 6 times the probable error, then it is highly significant, and in other case nothing can be concluded. Okay, so hope you have understood this. So solve this example by also using scatter diagram, solve by using other examples also with scatter diagram and with both the methods if possible, and also solve the examples given in the notes. Alright, so we'll see you in the next video. Till then, take care of yourself and study well. Thank you.